So good afternoon everyone, welcome to Nation Innovation. Now let's move forward to the next lecture. Here we will discuss the next three types of properties of a system, which are linear, non-linear, stable, unstable, and invertible and vertible and invertible type of a system. Okay, so now I'll discuss about the fourth one, which is linear and non-linear. Okay, so uh, basically we know that linearity follows superposition superposition principle. Okay, so basically superposition principle comprises of two properties. First one is homogeneity homogeneity and second one is additivity. Okay, second one is additivity. So basically what homogeneity is, if a signal xt produces y of t, then alpha times of xt will also produce alpha times of y of t. Okay, for additivity, if I have a signal x of t, it will produce y1 of t. If I have a signal x2 of t, it will produce y2 of t. So consequently, if I have a signal x1 of t plus x2 of t, then I'll get y1 of t plus y2 of t. So combinedly we can write like, so if I combine both the principles, so if alpha times x1 of t plus beta times x2 of t is equal to alpha times y1 of t plus beta times y2 of t, then a given signal is a linear a given system is a linear system is a linear system. Now let's take an example to understand this linear system. I'll take example. Let's take y of t is equal to t times x of t. Okay, so y1 of t will be equal to t times x1 of t, y2 of t will be equal to t times x2 of t. So if I take y3 of t, which is nothing but y1 of t plus y2 of t, so I'll get here this will be equal to t times, what is y1 of t, x1 of t plus x2 of t. Okay, now take this as equation number 1. Okay, now let's take another signal, name it as x3 dash of t. Okay, x3 dash of t. So x3 dash of t, name it as x1 of t plus x2 of t. Okay, so from our basic question, y of t was equal to t times x of t. So from here y3 dash of t will be equal to t times of x3 dash of t. Okay, so this will be t times x1 of t plus x2 of t. Name it as equation number 2. So if I compare equation 1 with equation 2, 1 is equal to 2. So the given system is a linear system. It is following both homogeneity as well as additivity. So combinedly it is following superposition principle. Okay, now let's move forward to another type of a system, which is the our fifth type of a system, which is stable and unstable system. Okay, this is the basic. This is very simple type of a system. So if the out for this, we only need to check for a bounded input. For a bounded input, uh, we should get bounded output. Okay, so there's a short form BIBO. Okay, if a given system follows this, then it is unstable system. Okay, so for a bounded x of t, like it should lie between 0 to infinity, we should have y of t, which should be between 0 to infinity. Okay, so if I take a normal signal which we have discussed in earlier class, like example we have taken, let's suppose x of t is equal to u of t. X of t is equal to u of t. So what was u of t? U of t was equal to 1 for t greater than equal to 0. So if I draw this signal, this is going from 0 to infinity. 0 to infinity, this is 1. So this is unstable. This is not following. This is not following BIBO. This is not following BIBO. So this is unstable. This is unstable. Okay, same goes for ramp also. For ramp is equal to t. For t, ramp is equal to t for t greater than equal to 0. So if I draw a t, this is also going from here to here. There is no boundation on ramp. So this is also not following. This is going till infinity. So this is also unstable. Okay, so like this we can clearly find that whether a system is a bounded system or an unbounded system, whether it is stable or unstable. Okay, now let's move forward to the last type of a system, which is invertible and vertible type of system. Vertible and invertible. Vertible and invertible. So for vertible, if for distinct output we get distinct, or if for distinct input we get distinct output, it is vertible. If input can be, if the input can be determined by output, then a given system is a vertible system. If the system follows one-to-one mapping, one-to-one mapping, then it is vertible system. Okay, then it is a vertible system. Now let's take the examples to understand this vertible and invertible system. Okay, so I'll take an example. Let's take y of t is equal to 4 times of x of t. Okay, so if I draw x of t here, I'll get y of t for x of t. So if I take 0 x of t, I'll get 0. If I'll take -1, I'll get -4. If I'll take +1, I'll get +4. If I take -2, I'll get -8. If I take +2, I'll get +8. So we can see that here it is one-to-one mapping. For say distinct output, we are getting distinct input. We can here see that distinct output, and here we can see that this is distinct input. Okay, So this is vertical system. This is vertical system. Now let's move forward to understand invertible. Okay, so if I take an example only, I'll make you understand by an example only. If y of t is equal to x square of t, so if I draw y of x of t, this will be y of t. Okay, so let's suppose I'm keeping x of t is equal to 0, I'll get 0 here. If I take minus 1, I'll get plus 1. If I take plus 1, I'll get plus 1. If I'll take minus 2, I'll get plus 4. If I'll take plus 2, I'll get plus 4. So we can see that for distinct input we are getting the same output. So it is not following one-to-one mapping. One-to-one mapping. So this is non-invertible system. Okay, non-vertical system. Thank you.